Climate, ever-changing and evolving. It shapes our planet and where we live, what we do, our survival. But today, it is changing faster than ever before. In 1979, climate specialists gathered at the first World Climate Conference. Observations provided a new perspective of our planet as an interconnected system of atmosphere, ocean, land, and life. The World Climate Research Program, WCRP, was established a year later. It provides a platform for international collaboration to understand the evolution of our climate system and the influence that humans have on Earth. At its inception, scientists came together to formulate a strategy to understand climate change, looking at the climate system as a whole, and by encouraging interdisciplinary work. Early projects included TOGA and WOS, which explored the importance of the ocean in the global climate system. TOGA focused on understanding El Niño events and their global impact. WOS studied the entire ocean circulation using unprecedented ship resources, innovative robots, and radar satellites. These elements are now part of the global climate observing system. Both projects used models to explore how the ocean's heat transport and storage underpin climate predictability. Such models are now essential for predicting climate and impacts such as regional sea level rise. Building on its success, WCRP established 4 core projects: GWEX, SPARK, CLIVA, and CLIC. GWEX has advanced our quantitative understanding of Earth's global energy and water budgets and the links between them. The project has supported vital improvements in climate and weather system models through better process descriptions and has driven the development and assessment of important global climate datasets that relate to Earth's energy balance, clouds, water vapor, precipitation, as well as surface fluxes of evaporation and sensible heat. SPARK focuses on investigating physical and chemical processes in the atmosphere and their influence on climate. SPARK scientists assess atmospheric dynamics, identify trends in long-term observations, and conduct model simulations. This work has formed a central component of understanding the hole in the ozone layer and the subsequent steps towards its recovery. With a focus on ocean-atmosphere interactions, CLIVA was established to observe, simulate, and predict the Earth's climate system. The project has allowed us to better understand the dynamics of the coupled ocean climate system and to identify processes responsible for climate variability, change, and predictability at all time and spatial scales. CLIC has been key in advancing research to understand Earth's changing cryosphere and its climate connections. CLIC research covers the Arctic, Antarctic, high elevation mountain areas, and broad regions that experience snow, lake and river ice, and permafrost. The connection between cryospheric observations, process studies, and regional and global modeling is an important focus for CLIC. WCRP research is critically dependent on observations, modeling, and process studies. Sustained observations, both on the ground and from space, have formed the basis of our understanding of how climate works and how it can change. WCRP has been instrumental in developing robust reconstructions of the past and recent climate and in improving model prediction skill on sub-seasonal to decadal timescales. Over the years, WCRP has played a major role in supporting the development, analysis, and intercomparison of climate models. This can best be seen with the success of CMIP. This project is an international effort involving thousands of researchers and many modeling centers, which has led to major advances in climate science and which underpins recent Intergovernmental Panel on Climate Change Assessment reports. As societies plan for the future, WCRP has recognized the importance of regional scale across the program, particularly in Codex, which works to better understand regional and local climate phenomena and develop useful regional climate information. WCRP also prioritizes research problems that are hard but important to solve. Grand challenges on the consequences of melting ice, clouds, circulation and climate sensitivity, feedbacks in the carbon cycle, weather and climate extremes, water availability for food production, regional sea level change and coastal impacts, and near-term climate prediction are all underway and furthering our understanding of the important areas of research. Looking to the future, WCRP's new strategic plan will focus on 4 core objectives, which will look to support and facilitate the advancement of science through an understanding of the climate system, to push the boundaries of predictions to better understand climate across all system components, to assess the long-term responses, feedbacks, and uncertainties around our changing climate, and to bridge the gap between climate science and society by supporting innovation and knowledge around our Earth system. WCRP's work has provided the foundation for some of the most ambitious international climate treaties and policies impacting life on Earth. Over the past 40 years, this international network of passionate individuals has given its time and energy in pursuit of answers to the most complex scientific challenges on Earth. As we welcome a new generation of scientists to the field, WCRP will continue to facilitate the international coordination of climate research that is needed to support a more resilient society. The story is not over yet, and the answers arrived at by science are clear. Our climate has changed and will continue to change. We must continue to bring the world's best research to the table to meet the challenges and take advantage of the opportunities to come.